Okay, in this lesson, we're going to be talking about how to solve exponential equations. But in this lesson, we're going to be solving exponential equations without using logarithms. You're going to see as we move on a little bit farther that we can use logarithms to solve these things. But there's a couple of cases that we can do to solve these things like without getting logarithms involved yet. Okay, so here's the first way. So we can solve exponential equations if both sides can be expressed with the same base. All right, so officially this is how this could be written, right? B of u is equal to b of w, like if that's the case we're dealing with, then we can say u is equal to w. Okay, and doesn't that make sense? I'll just kind of write it like, let's see why that makes sense, right? What this means is if I had something like 2 to the power of x is equal to actually 2 to the power of 4, let's say, is equal to 2 to the power of, and then what would it be equal to? Well, it'd be equal to 4, right? They would be equal to each other. So what this thing is really saying is that if I had, 2 to the power of x plus 1, and then that's equal to 2 to the power of, let's say, 3, then what I can do is say, okay, whatever 2 is here, whatever the exponent is, those things are definitely equal to each other, right? Because if they're equal, right, if I'm setting them equal to each other, then those exponents have to be equal. So the next step here is just to say, okay, well, as long as those bases are the same, then I can just set x plus 1 and 3 equal to each other. So I can say, okay, then x plus 1 is equal to 3. And then do a little algebra. So then I would subtract 1, subtract 1. So we get x is equal to 2. And doesn't that make sense? X would be equal to 2 there, wouldn't it? Because that'd be 2 plus 1 is 3 to make those the same. Okay? So that's all this is really saying. So like this one, I don't think you guys will find too bad. The problem is that sometimes it won't always be so nice where they're just automatically written like with the same base. So I'll show you some examples of that, and then I'm going to go through some of the homework problems too. So, all right. So if we had this example of 8 to the power of x is equal to, and then 128. Okay, well, those aren't the same base yet, but what we can do is we can rewrite these things with, a common base, right? So what I can do is say, okay, well, 8 to the power of, 3 or anything else isn't going to work here to make a base of 8. But what if I rewrite the 8 as 2 to the power of 3? Right? So now that's 2 to the power of 3 to the power of x, right? I've just rewritten the 8 as 2 to the power of 3. And then that's equal to 2 to the power of, and then this is 2 to the power of 7. Okay? Now, if I have 3 to the power of x, remember if you have a power to a power, you multiply. So this would really be 2 to the power of just 3x. And that's equal to 2 to the power of 7. So now that I have those same bases happening, what I can do is actually just set the exponents equal to each other. So I could say, okay, if that's true, I can say, therefore, if you see that like triangle with the dots, therefore, 3x is equal to 7. And then all we'd have to do is just divide by 3. Divide by 3. So x is equal to 7 over 3. All right. Okay, so I'm going to go through some other examples like that in the homework. So yeah, you can look at these examples. They're good references, right? Now, the other way that we can solve exponential equations is by graphing, right? We can always graph to things to figure out what the answer is. So if we were given, an expression like this, like 2 to the power of x plus 5 and 7 to the power of x is equal to 7 to the power of x minus 2, right? This is a tough one to solve, right? We could use logarithms that I'm going to teach in the next lesson to solve for this thing, but we can't make them have the same base, right? I can't write this 7 as like 2 to the power of something is 7, right? So that method isn't going to work. I can't write them with the same base. So all we're left with is to graph both of these as lines, right? Like graph this as my first one, so that'd be like y1 or f1 of x, right? Either can be written either way. So maybe that'd be like y1, and graph this one as y2. And then a solution to a system of equations like this is just where they cross. So that's what this would look like, right? So solving this one, if you solve this thing, right, you'd figure out where they cross. And then remember when you're looking at a point, like here, right? That's my x value and that's my y value. I'm looking for my x value, right? That's where this happens, right? So I want to know what x is equal to in this case. So in this example, I'm not really that interested in what y would be equal to at that point. So I'm looking for the x value there. Okay? So my answer would be 1.141 in that case. It would actually be like an irrational number probably that, you know, would keep going forever, but you know, you could round it to that. Okay? So here, let's do another one. We will actually graph this one. Okay? So all right, let's go get things ready here. Okay. So I pulled my TI-84 up, and we want to solve this expression graphically. So 2 to the power of x minus 1 is equal to 3 to the power of x minus 2. All right, so what we have to do here is I'm going to go to my y is equal to, and delete out the ones that are already there. And I'm going to go to zoom standard just to start over as well. So zoom 6. You might already be there, but that just brings me to having, like, you know, I can see 10 up, 10 to the left, 10 down, 10 to the right. Okay, so that changed my window. All right, so back to y1. And then I'm just going to type it in, like, each one of it individually, right? So 2 to the power of x minus 1, so that's going to be 2. And then to the power of is going to be your little hat, right? So 2 to the power of. And then you can just write it all up here now as x minus 1, or just to make sure, we can put it in brackets too, just like it is, like it's written. So then x minus 1. And then I'll close my bracket there. Okay, so that's my first one. So then I'm going to go down and put in my second one. So now we have 3 to the power of, and then I'll put in brackets, x minus 2. And close the bracket. All right, let's see what we got. So now I'm going to go graph. All right, so there goes that one. Classic exponential curve. And we got our other one coming. So that should be pretty good, actually. We can see that it does cross right here. If we wanted to, we could change our window settings. So I'll just remind you guys with that, right? So right now I'm seeing 10 to the left. I don't really care about the left, do I? So I'm actually going to change that maybe to like -1. So like, you know, clear, so -1. My max, yeah, that was pretty good. Y, and then Y minimum, I'll change that to -1 as well. You didn't have to here. Just want to make it a bit more clear. So -1. And let's see what we got now. It just made it so I can, like, you know, it's just a bit bigger on my screen here, right? So now when it comes past, we should see it a bit more clearly. Come on. And then crosses right there, right? So that's what I'm looking for, that spot right there. So now let's go to calculate, right? So calculate's up here. So we're going to go second, calculate. And now I'm looking for the intersection, right? I'm looking for where those two things cross. So that's going to be 5, or you can go down too, it doesn't matter. I'll just push 5. And then remember the way this works is, so my little cursor guy was a little off the screen. He was kind of up there, so I had to push back a few times to see him again. But anyway, so right now it's saying first curve. So what that means, you see how it's like in blue? It's asking me, is the blue line the one of the lines I'm talking about? So I could actually push this wherever I wanted on the line. But, you know, sometimes these things cross twice. So a good habit is just to kind of, like, you know, make sure you're on the line, but just kind of do it close to where you think they cross. Okay? And then push enter. And now it's saying second curve. So now it's talking, or it's saying, is the red one the other line you're talking about? And I say yes. So I'll push enter. And now one more time, it's saying take a guess, question mark. So then I'll push enter once more. And then there you go. So there's my answer. You can see it a bit more clearly here. So x is 3.7 and y is 6.5, right? Okay. So yeah, good enough. So that would be your solution, right? So your actual solution here, though, maybe I should state that. Your solution would be 3.7. Right? So that would be 3.7. So x is equal to 3.7. And technically, you shouldn't say equals. That would be approximately equal to. Because these things would be rational or irrational numbers. And I'll show you in the next lesson when we start using logarithms, we end up getting irrational numbers quite a lot. So that's why these would actually go on forever and never repeat, right? But yeah, for now, we'll say it's approximately equal to 3.7. Okay. Now, for describing these things, that's what this question really was. It was saying describe what's happening here. Well, you'd just describe what we did, right? We graphed y1 as this side, y2 as this side. And then you also should have your window settings there, right? So the window settings were fine to begin with. This is just another way of writing it out, where the first one, right? This is like our x minimum. This is our x maximum. And then the 1 here is our scale. And that was, you know, what the ticks go up by. So scale of 1 means that like every tick was 1. Okay? Because if I change that in my window settings, right here to 10 or something, then you wouldn't see it. You know, you wouldn't see those ticks, right? Or here, I'll change it to 5 so you can kind of see what I mean. So if that's 5, and then if I graph that, do you see how the first tick just starts at 5? So that's all that is. Typically, you can just kind of leave the scale. It doesn't really matter. The only reason why I'd ask you guys to like write this down, like your window settings, would just be to actually tell whether or not you did the question, right? Because if your window settings were like, you know, way off, and you said that you found the intersection, but I can tell from your window that you weren't even looking at it, then something's a little wrong there, right? So that's why I have you sometimes write your window settings just to kind of show. That's kind of like showing your work when you're graphing. Okay. All right. So here, let's jump into some of the homework questions. Okay. So this one says, using a graphing calculator or the Desmos calculator, find the solution accurate to 1 decimal place to the equation below. So now just one thing with the Desmos calculator, it is great. Actually, I really like the calculator. The only problem is that you're not allowed to use this on any diploma or any of your exams, right? Because I can't allow you to have a computer sitting there with you while you're doing your questions, right? It would make cheating too easy. So it's fine, like if you don't have anything else, but you know, you should know the steps that I just did with your TI 84 or your TI Inspire. Yeah, okay, but anyway, I'll show you on this one how that would work too. So if you go to this Desmos calculator, then, well, what we want to do here, right? We want to graph 4 to the power of x and then just 37. Okay, so because this side would be like my y1 and then this side would be like my y2, even though 37 is just a number, right? I'm still going to use that one. So here, let's type, so 4 to the power of x. So that'll be our first one. So it'll be y is equal to 4, and then to the power of on this one, I think you can push here and you can do like, you know, squared or like raise things to the power somehow. But the easier way is probably just going to be to go shift 6, right? That's that like little hat on your keyboard, and then x. And there you go. There's my exponential graph. Okay. I actually didn't even need the y is equal to on this one. I could have just written 4x and it would have been fine. Okay. So there's the first one, and then the second one, I forgot already, it was 37, right? So then this one doesn't work if I just put in 37 though. It doesn't know what I'm talking about. So I need to explicitly say y is equal to 37. All right, so now why don't I see that, right? I saw the first one, where's the second one? Okay, well, the issue is here is that y is equal to 37 is a horizontal line at 37. So I need to see a little higher. Now, the problem is the recording I'm doing right now, you can't actually see my button. Maybe I can grab my, there you go. Pull it down there. If you go to the little gear icon here, so the graph settings, this is where you can change it. This is like your Windows settings in your TI 84. So here with your x-axis and your y-axis, this is what I'm able to see, right? So x is like -10 to 10, so I can change that. This one's probably fine though. I want to change my y-axis so I can see at least up to 37, right? So I'm going to change this to maybe, I don't know, 50. And then there you go, right? I can see that thing more clearly. Okay. And then this one is nice because the last time, remember how we had to click on one graph, click on the other, take a guess. This one, you just click it where you think the answer is, and it tells you what it is. So the answer here is just 2.6 or 2.605. It again, though, is like rounding those numbers, right? So that's not the exact answer. But so let's go back to our question. And so the answer was 2.6, yeah, and this one has all the numbers right. So accurate to at least one decimal place. So make sure when, this one doesn't actually say that, but it tells you here, make sure you're actually doing what it says in the question there, right? Sometimes it'll actually say in the question, accurate to one decimal place or something like that. So, okay. Use the like basis property to solve this equation. So again, I just want you to know you could always graph it, and that you can always solve it that way too. But we're going to use the like basis property to solve this one. So let's do that. So we're going to have 5 to the power of x is equal to, okay, and then it's actually already told me that I'm looking for like basis property. So I want to write this 625 as, well, 5 to the power of something, right? And maybe you don't know, right? That's fine. Like, people don't usually memorize these things. You could just try some things out, though, right? You go, okay, well, what about 5 to the power of 3? And you're like, well, 5, oh yeah, 125, right? So it's not 125. So what about the next one? 5 to the power of 4. Yep, that one did it, right? So I can rewrite 625 as just 5 to the power of 4. So now if that's written with the same base, then now I'm able to say, well, x is equal to 4, right? You're able to say, therefore, x is just equal to 4. All right. Use the like basis property to solve this one. So now in this case, we've got 6 times 2 to the power of x is equal to 96. Okay, so now the problem is here is, you probably know this thing, is that I have 6 times 2 to the power of x, right? So the way you're going to handle these ones is to first, well, get that 6 out of there, right? I want this just to be some base to the power of x. So I'm going to divide this side and this side by 6, right? So then what we'd end up with is 2 to the power of x is equal to, and then 96 divided by 6 is 16. And now we're kind of set up. We're ready to kind of rewrite this one. So now this would be 2 to the power of x is equal to, and then this would be 2 to the power of, okay, well, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4, right? So in the end, our answer is just x is equal to 4. The answer is not going to be 4 in every one of them, by the way. Okay. Okay, next one. So now we got some weird things happening here, right? So let's look at this. So it says 1 over 5. 1 over 5. So we've got 1 over 5 to the power of n is equal to 125. Okay, how am I supposed to write these with like bases, right? This doesn't look any like, maybe the 5 and the 125. I know that 5 to the power of 3 is 125, right? So 5 seems like we're on the right track here. But this fraction, here's the issue, or here's the solution to this fraction here, is that when I have 1 over 5, I can write that a little different, right? Isn't that the same thing as saying 5 to the power of -1, right? 1 over 5 and 5 to the power of -1 are the same thing. So far I've got 5 to the power of -1 to the power of n is equal to, and then 125, let's do that now. That's the same thing as 5 to the power of 3. Okay, now a power to a power, I could have written this thing right off the bat as just 5 to the power of -n is equal to 5 to the power of 3. Okay, so you can probably see what the answer is already, but let's just, for good measure, go one step farther. So I can say, okay, well, therefore, I can say negative n is equal to 3, right? I had the bases equal to each other. So now, in this case, I'm just going to say, well, okay, this is really like negative 1, right? So if I divide both sides by negative 1, come on, divide by negative 1, then I get n is equal to negative 3. All right, that one's pretty set up for you. I'm going to let you guys give that one a go. Well, yeah, I'll do the next one. Next one will be a bit more involved, so and similar concepts. So, okay, so we've got 1 over 2 to the power of x plus 1, and that's equal to 2 to the power of 4x plus 6. All right, so I got a feeling something to do with a 2, and this is really similar to last time, isn't it, right? Let's rewrite this fraction as, instead of 1 over 2, let's call that 2 to the power of negative 1, right? 2 to the power of negative 1, and then just careful on this, right? Because it's like 2 to the power of negative 1, and then that's times x plus 1. Okay. So yeah, so it's written like so. Okay, and here, I'll write out the next one here too. So now we've got 2 to the power of 4x plus 6. So now careful on this one, because I've got negative 1 times x plus 1. Well, it's really like negative 1 times this in brackets, right? Because it's times that whole thing. So we have to like distribute the negative onto this thing. That was weird. Anyway, you get the idea. There. Okay, so in the next one, so we'll write this as 2 to the power of, and then this would become negative x minus 1, right? Right there, that minus 1 is probably where people will make a mistake. And then is equal to 2 to the power of 4x plus 6. So now that I have it written in that form, I can say, okay, well, therefore, I can make the tops equal to each other, right? The exponents equal to each other. So we'll say negative x minus 1 is equal to 4x plus 6. Okay, and then the next step, we're going to get our x's on one side and our numbers on the other. I'm going to bring this x over to this side to keep things positive. And I'm out of room. Sorry. Let's go up here. Okay, so then in the end, so I've still got negative 1 is equal to, and then 4x plus x was 5x, and then plus 6. And then I'm going to bring this side over, so minus 6, minus 6. So we get negative 7 is equal to 5x, and then divide by 5 and divide by 5. So negative 7 over 5 is equal to x. Okay. Okay, so that's it for that lesson. Remember that there are videos for most of these questions, so utilize those. And the other one, guys, I know that you can do a lot of these questions by just graphing them every time, right? Like you could graph these and solve it that way. That's not going to be in your best interest. I'm going to make you guys' questions on your tests are typically worded in such a way, especially your diploma, where you have to know how to set it up with the like bases, right? So don't just assume that you don't have to do this step, because yeah, I'm going to make it at some point. Okay, so practice those skills. Even though you can check, right? You can graph it and check to see if you're right, but I guess you can check with because you have your answers. But yeah, so make sure you're actually practicing these, guys.